Welcome to Real Rover. I'm your roving host, John Craig. Real Rover へようこそ、Craig John でございます。Introducing you to people you would never have heard of if it wasn't for Real Rover. Here we go. Today's guest on Real Rover is Wallace Thornhill, who earned a degree in physics and electronics at the University of Melbourne, Australia, and began his postgraduate studies. Before entering university, he had been inspired by Immanuel Velikovsky's best-selling book, Worlds in Collision. However, the lack of curiosity and the frequent hostility toward the challenge to mainstream science convinced Thornhill to pursue an independent path outside academia. And today he's going to be talking to us about the electric universe theory. And based on his long-standing work in this field for over 20 years, in 2010, the Telesio Galilei Academy of Science awarded him and several others its 2010 gold medal, presented on the 12th of June, 2010. So it's my great privilege and honor to welcome Wal Thornhill to Real Rover. How are you doing, Wal?
I'm doing fine, thanks, Ekan, and thanks for the invitation.
Before we start, there's one thing I would like to say, which is, happy birthday to you. It's tomorrow, I know, but your birthday tomorrow, so happy birthday to you. Yay!
The secret's out.
You've been in the field a long time,
Yes.
battling some rigorous opposition for your introduction of what mainstream science says is a completely loony idea, the electric universe. And in fact, to prepare for this interview, I did a web search on electric universe theory, which anybody can do on Google. And the second thing that comes up is truly horrendous. It's Rational Wiki. Have you seen this?
Yes, it's actually should be renamed Irrational.
Just to give our listeners an idea of how rigorous the opposition is to new and revolutionary ideas, this so-called Rational Wiki says that the electric universe is an umbrella term that covers various pseudo-scientific cosmological ideas built around the claim that the formation and existence of various features of the universe can be better explained by electricity and magnetism than by gravity alone. As a rule, EU is usually touted as an ether-based theory with numerous references to tall tales from mythology. However, the exact details and claims are ambiguous, lack mathematical formalism, and often vary from one delusional crank to the next. This is rude. How does that make you feel?
I don't bother reading these comments because it tells you more about the person who's writing it than it does you about the electric universe. In fact, one of the complaints is that the electric universe hasn't got a lot of mathematics. There's a very good reason for that, and that is that the very first thing you must do when you're doing physics, and I emphasize physics, which is all about the physical universe, is to have some physical model in mind. And this is something that's completely lacking in modern science. It's all become mathematical mysticism. And when you realize that simple symbols on the board, like E equals mc squared, there is no definition in physics of energy, there is no physical definition of mass, and the speed of light is not understood because light itself is not understood. And yet that's the thing that we examine the deep universe with. So when you realize that E equals mc squared, there's no scientist on earth can tell you what it means physically, they should pull their head in.
I agree entirely. However, in one of your lectures, you showed a picture of a physicist standing in front of a blackboard that was about 20 feet wide and 10 feet tall, absolutely covered in equations, mathematical equations, which we've been, I believe, bamboozled to believe represent some kind of a reality. But how many people on the planet can look at that and actually connect it to what you are calling physics? I doubt it. And I know that it was your meeting, your genesis in the electric universe theory, as far as I can see, was meeting a truly remarkable man whose books were actually burned in the 20th century, not the Middle Ages. Tell us about that. Tell us about that incredible meeting.
Yes, the book was Worlds in Collision, and the author was Dr. Emanuel Velikovsky, who was one of these polymaths, you know, who's good at everything he did. And I was given the book to read because as a kid I used to love astronomy, and my father knew this, and he gave me a copy from the library to read when I was more or less halfway through high school. When I read it, I thought, wow, this is an amazing piece of work, because what he did was to take a forensic approach, you know, like police lineup. You look at all of these people giving evidence, and you realize that each one tells a slightly different story, and you've got to try and work out what are the actual facts of the matter. So this is a forensic analysis of all of these myths and legends, which are generally equated with, you know, fairy stories. And the thing that he found, and it's easy to demonstrate, in fact, many scholars have found the same thing and written it up in different ways, is that all of the stories, it doesn't matter where you go around the globe, have common elements and common themes. You know, they have the hero saves the damsel in distress. You have the gods in the sky. You have this kingdom of heaven. Something or other was going on in the sky which looked like a kingdom. And then when you also read that the actual planets, and they named them, battled with thunderbolts, you think, well, what was all that about? Of course, it's easy to dismiss this and just say that the thunderbolts are the same ones we see in the sky today. But when you see their sculptures, they are nothing like a lightning bolt that we see today. They have shape, they have complex shapes. And those shapes we now see in the highest energy electrical experiments on Earth at Los Alamos Labs, where they have a machine called the Z-pinch machine, where they can feed all the energy of rooms full of high energy storage capacitors in a fraction of a second into something that's less than the size of a baked bean tin. Now, when they do these experiments, the energy released, of course, is pretty dramatic, and they observe what goes on from about a kilometre away through telescopes. And then once it's over, they go back and they reconstruct the laboratory. So you get an idea of the energy. In fact, it's more than all of the power stations on Earth, maybe several times over, pumped into this baked bean tin, so you can imagine. The images that they see of this high energy plasma is the same as was sculpted by these ancient people who were trying desperately to have us understand something that we just don't see today.
What did they see?
What they saw were planets up close and scary. They saw when the planets came close to one another, they would exchange these plasmoids or thunderbolts of the gods. And the results were quite devastating on planetary surfaces. And Mars was the classic one, where the North American Indians, for instance, called Mars Scarface. And what was the first thing they discovered when one of the Mariner spacecraft sailed past Mars? Was this colossal gash which extends a third of the way around the planet and has no real geological explanation. They've made up stories, of course. This is typical of geology. It's a descriptive science more than so-called hard science. And in fact, the ancients must have seen Mars close enough to see all of this happen without the use of telescopes.
Of course, they didn't have telescopes. What kind of time period do you think we're looking at here, Wal, when they saw this?
Well, the effects on the Earth's weather and that, of course, was pretty dramatic. And it was the time of the last ice age.
I
So
see.
all of those wild excursions in temperature and that were a result of the Earth shifting its orbit. Because what happens is, and this is something that it's taken me all my life to understand, is that those thunderbolts, when they're exchanged, actually change the apparent mass and gravity of a body so that they move apart. And what's more, their nature has a system of avoiding collisions between planetary bodies. Now, this was important to understand because one of the chief arguments of the astronomers, and the reason they burned his book, his bestseller, by the way, for many months on the New York Times bestseller list, was that it disobeyed Newton's law of gravity, or Newton's laws of motion. Well, appealing to man-made laws against something that was witnessed by people around the entire Earth is not a sufficient argument, in my opinion, which is why I pursued it while I was at university. And what I did was to read the stories of the most ancient stories and legends of people from around the world, including the Australian Aborigines. You know, the Australian Aborigines are recognised as being one of the oldest groups of people on the planet. You know, the history, according to the archaeologists, extends back 40, 50, I think recently it's gone to 60,000 years. Well, whatever it is, be that as it may, their oral traditions are the most accurate that I've seen, because they specify things in the sky in terms of things that they saw on the Earth, which were what we had pieced together before we actually bothered. This is all years later, of course, after a lot of research by other people. They actually tell a story which is quite amazing. In fact, there could be no science fiction story written which could match it. And yet it must have been a fact, because there was no way they could make this up. Now that
Why would they make it up, really?
Why would they make it up? And why would they keep that story for more than 10,000 years? It's because they felt that this was the most important thing that had ever happened in their existence. They witnessed what they thought was going to be the end of the Earth and everything. And when it wasn't, they really wanted to tell their story. And you can imagine why these legends and so on from around the world all have these common elements. You know, the battles amongst the gods, the planetary gods, the hero planet that saved the Earth from, the chaos monster. All of these things, and even the way the stories are structured, we still repeat in modern stories. You know, you have this crisis, and then you have resolution and a catharsis and all this kind of thing, and we still repeat it in our warlike behaviour, which is one of the insane post-traumatic stress disorder kind of reactions that the whole human race has and doesn't understand.
Well, I think that that trauma is really important for people to understand, because Velikovsky, tell us a little bit about his background. Wasn't he a disciple of Freud?
Yes, he actually did some original research in the field, and his last book, which I consider to be an important message for mankind, but it's practically unknown, was called Mankind in Amnesia.
Huh.
And he was asked in a television interview in Canada back in 1972, I think it was, can you put the human race on the couch, the psychiatrist's couch? And he said, in a sense you can. And he said, like somebody who suffered a terrible trauma in their life and cannot face it, it keeps popping up subconsciously. And the impetus then is to repeat the trauma in some way, either observing somebody else undergoing it, like warfare, or visiting on yourself, or going to horror movies and things like that. And you wonder why all these disaster movies have such a following. Here's your answer. It's a kind of you witness, or at least you try and create the situation where you relive it in some sense. And afterwards, there's this catharsis, and you feel as though, okay, I've dealt with that, but you haven't. And so you keep repeating. This is why we go through these cycles in our civilizations, as we call them.
As we call them.
Yeah. Now, Velikovsky felt that because at the time, of course, we had the Cold War and the threat of nuclear war, and he felt that if mankind didn't learn this lesson, he was at risk of repeating the doomsday scenario using nuclear weapons. In other words, we felt we had the power of the gods to wreak destruction on one another. And this division between people came about, I think, because those who survived felt that those who perished were being punished and that they'd done something wrong. So you had the them and us. We're in the right, God loves us. Those who died, worshiped the wrong gods or thought the wrong thoughts, whatever it is, and we still do it. We have to learn that we're all connected and that our survival depends on us understanding that, and also that we're connected intimately to the earth in ways that are not understood at present, except by people in the natural therapies and so on. And that's one of the aspects of the electric universe, is that it's a cosmology that covers any subject you like to name, which is what a real cosmology must do.
A real cosmology must do. And some listeners may not be familiar with the idea that all of our so-called modern science comes from cosmology, physics, chemistry, geology, biology. All of these are subgenres of the big daddy, which is cosmology. How did the universe start? Where is it going? And where is our position in it? And Velikovsky named his book Worlds in Collision. So I just want to get back to this point, because almost every modern educated person has a fixed idea that the solar system is absolutely steady, that the 9 planets, or 10, however you want to look at it, revolve endlessly at the same distance from the sun. There's nothing really moves. We may have a comet every now and again, but these ancient people saw Mars up close. Now, how can that be? How can a planet get that close to us? Nobody's got any paradigm for that these days.
That's true. And the basic problem is the fundamental physics is lacking. We've had Newton and Einstein describe gravity with their equations, but not explain it. In fact, Einstein did away with the force of gravity, which is pure nonsense. How does a pound of sausages on the scales stretch the spring or tip the balance if there's not a force involved? To say that it's warped space or some such thing is absolute nonsense, because space is a non-physical concept of locations in 3 dimensions. That's all it is. It's not a thing. It's not something that can twist or bend or all this sort of nonsense. And time is not understood either. You can see a huge confusion when people talk about time, because they say, oh, there's an arrow of time. Well, I say, well, point me in the direction. What direction is time facing? Because, these are 4 dimensions means 4 vectors, and a vector has direction as well as magnitude. And you say, and how long is this time in inches? Or, This is one of the critical things. The electric universe actually defines each of these things: mass, energy, time. And would you believe you have to go back to the classical physics of the 19th and earlier centuries to actually turn around and then come forward, because those guys had more idea of how the universe worked than these modern people fiddling with mathematics and computers. A computer model can't prove anything. All it does is reflect back to you whatever you put in. And because there are so many knobs to twiddle on these models now, so many particles, so many forces, and they love to invent new ones just to confuse people even further, the whole thing has become sheer nonsense and virtual reality. And yet they give Nobel Prizes to people who help make virtual reality films about black holes.
I was sitting watching National Geo or History Channel with my son, who hasn't had really any science background, but he's inquisitive. And we're watching one of those famous presenters, famous physicists, with all of these computer simulations and diagrams about warped space and multiple dimensions, superposition, quantum physics. It was like something of Alice in Wonderland. Now, I knew this because I followed the work, but my son's completely innocent. And I turned around to him and I said, well, what do you think about this? I mean, do you believe it? And he says, no way, man. That's not the way it is. And that's a regular open-minded person, but somehow we've been bamboozled by the mathematicians to believe that we cannot understand the universe, only they can. And I think Velikovsky came and he just planted a gigantic bomb in the middle of all of that and questioned the entire paradigm, which is why, of course, they burned his books. But when you met him, Wal, did he look like he had been jaded, like his whole life had been a waste? How did he appear to you as an individual human being?
No, he was, I think anyone who is motivated, like I've been for most of my life, with an idea, and you have not yet found anyone who can argue sensibly against it, then you feel quite justified in continuing and ignoring those who obviously haven't even bothered to learn what it is they're fighting against. And this is the case with most of the people on Rational Wiki and all the other blogs that say they're tearing the electric universe apart. Everything they attribute to the electric universe shows that they just haven't bothered to read it or even attempt to understand it. And this, unfortunately,
indeed,
is a trait. You know, it's a human trait that anything that's really alien to your roadmap is dragons at the edge of the map, you know, and you're not going to go there. And psychologists, and there's a fellow in England, Dr. Ian McGilchrist, who's making a name for himself in this area, has looked at the way the human brain operates when you're being educated. And it turns out that their education systems actually disable the critical faculty.
Oh.
You end up believing a whole lot of things that just aren't so. And of course, when you get to university, you're supposed to be able to look at things critically, but they don't present you with alternatives. There's just this onwards and upwards Darwinian type of progression through science to perfection and a theory of everything, as if, you know, we're almost there. It's absolute nonsense. When you read the controversies and the context of the historical arguments, you realize that a lot of the laws and things that we accept now were based more on politics and individual characters, those who dominated the discussions. And it's no different today. We have some people who dominate the discussion and tell us what's right and what's wrong, when in actual fact, if you really want to learn, you have to investigate the history. And history is something that science is abysmal at teaching.
Indeed. And I think Arthur Schopenhauer had said that all truth passes through three stages. First, it is ridiculed. Second, it is violently opposed. Third, it is accepted as being self-evident. And I think that in your case, we're not near the place yet where it is accepted as self-evident. Certainly not self-evident if you haven't studied the electric universe. And I would counsel our listeners to actually go there and study it. You have a phenomenal body of work out there on YouTube. The playlist alone for Thunderbolts is absolutely stunning. And I just picked up one part of one video out of hundreds that you've produced with your colleagues over the years. And space.com says, strangely, auroras on Jupiter seem to be powered by a mysterious physical force that astronomers haven't been able to identify. According to the mathematical calculations, I stress, Jupiter's auroras should be about 10 to 20, 30 times more energetic than Earth's. But Juno has seen auroras that are hundreds of times stronger for no apparent reason, again, which I stress. So here we have so-called experts clearly admitting that they haven't got a clue what's going on in Jupiter, never mind interstellar space, never mind galaxies billions of light years away. And yet they blithely say something like that, but they don't come up with an alternative explanation. It's always the model just needs a bit of tweaking here. So could you comment about model tweaking and how science actually operates these days.
Okay, once you're aware of what's going on, you'll notice the words "not completely understood" used in every other paper in science. That means we've got no idea. There's so many things that they say, we've got these observations which are not completely understood. In fact, giving the impression that we're almost there when in fact they're not even on the right track, you know. The progression, the history of all of this is very interesting. In fact, I spend a lot of time reading people who I consider in the future will be recognized as the true pioneers in science. We have a lot of, I mean, we've gone completely off the track since Einstein when we stopped doing physics and started doing mathematics. And I was looking the other day at there's a compendium of all of the dissident scientists on Earth put together by a fellow called Jean de Clément. And would you believe it runs to 1,460 pages?
My goodness.
I would say the majority of them have good, cogent arguments against Einstein's nonsense.
Huh.
But we don't get a look in at present. I think the question is, how bad does it have to get before those in charge in science take notice? And I feel that the answer must come from the public being educated in the alternative, which is the electric universe. And those who do come to it with an open mind, not looking for ways to argue against it, which is what the skeptics do, say for the first time, I understand. And what's more, they say, I can't watch the science programs on television anymore. I get angry. People want to throw something at the TV.
That's exactly what happened to me.
Because they can see all of the false assumptions that are just thrown in as facts when they're not facts at all. They're just, you know, something they've made up, a cover story. And of course, humans are much better storytellers than they are scientists.
Yeah, and thanks to computer technology, it's very easy to whip up a computer-generated simulation of a black hole, and everybody looks at it and they go, wow, there must be a black hole there, because why would they make it up otherwise? It must be real. And having followed your work now for 15 years, you completely devastate these fixed ideas. There are no black holes. The universe ain't expanding. The universe is smaller than we thought it was. The universe is super connected instantaneously at all times, every single part of it. And I remember you had once said that, okay, if the speed of light, we know the speed of light, and it takes how many minutes for the light to come from the sun to Earth? 8.2 minutes or something? And you had said, well, let's just do a thought experiment like Einstein did, and let's say the sun disappeared now. Would it take 8.5 minutes for us to figure it out?
Yes, the thing is that that's a very good demonstration of the fact that Einstein's speed limit is nothing of the sort. All is a speed limit of an electrical disturbance that we call light through a medium, which Einstein discarded and never said how you could actually do that and still have light transferred through empty space. So, okay, we must have a direct connection to the sun. The Earth and the sun must know where each other are at any instant, because if not, the Earth is orbiting a spot where the sun was 8.5 minutes ago. And that's exactly the same as spinning a rock on the end of a string around your head. Your hand is slightly ahead of the rock all the time, so it keeps the rock orbiting around your head. Now, if it wasn't for the string, the rock would fly away, which of course, if you let go of the thing, the rock will fly. It's, you know, a well-known weapon of war in olden days. So if gravity operated at the speed of light, all of the planets would be slung out of the solar system in a fairly short time, measured, you know, a few million years. Since they don't seem to be shifting their orbits to any sensible degree, then this shows that Einstein's speed limit has nothing to do with gravity. And in the electric universe, there is a single force. This is one of the aspects of classical physics, was these guys were always trying to simplify things. And Newton and Faraday and others all said that if we could find some way of proving that gravity is an electrical force, that would be a discovery of enormous potential. Well, the electric universe has shown with a physical model how this can be so. And in
So
fact,
gravity is a secondary effect of electrical phenomena. It is not the primary ruler. It is actually an effect, which is probably why we can't tell how it works, because it's not the source, it's the effect. Is that correct?
yes, it's an effect of an electric force on matter itself. Matter responds by actually distorting slightly. And because all matter that the universe is made from is electrically charged, if you separate the charges a tiny bit, they form what's called a little electric dipole. Now, it turns out that both magnetism and gravity are the same kind of force. They're both dipole forces. Now, when I say that, this changes everything, because everyone thinks gravity is only attractive. And everyone's been wondering, how can I produce anti-gravity, as they call it? Well, since it's a dipole force, it's just like a magnet. If you can get the two similar poles facing one another, they will repel each other. And this is what planets do, and stars, and the rest of all the galaxies. And it was discovered observationally by an astronomer who in future will be regarded as the second Galileo, because he was purely an observational astronomer and theorist who was one of the most outstanding astronomical newcomers back at the time of Hubble, and in fact worked for Hubble for a while. And he has proven that the universe is not expanding, it appears to be static. And he said, this can only be so if gravity is repulsive. So he went back through the history books and he found that a colleague of Newton, and Newton himself, and another guy called Lesage, all came up with the idea that gravity would also work if it was a repulsive force, because then you have the sun repelling the planets and the rest of the universe pushing in on the planets, and the result is a balance where the orbits are all set up to balance the repulsive forces. It would also explain how Velikovsky could have his careening planets without actual collisions. So his title was a little misleading. It was worlds in close approaches.
I see.
As worlds in collision. And one of the aspects of it is that gravity is modified by the electrical environment of the body itself. So when they exchanged thunderbolts, they actually shifted their orbits, and I figured it out in my little bit of mathematics, and it's just high school mathematics, showed that it works to move the orbits away from one another until they get to a point where they are not interacting electrically to any great degree. And of course, any body that's discharging strongly, like a comet is an electrical body traveling in the sun's electric field, discharging, that's what that huge plasma envelope, which can be as large as the sun, is produced by. They're electrical forces. Gravity can't do that. Gravity around a rock a few kilometers wide cannot hold something the size of the sun around that comet while it's whizzing around the solar system.
Evidently.
Yeah. Anyway, the thing is, while it's discharging, its gravity and its mass are changing. And astronomers know that comets exhibit what they call non-gravitational forces. That's their sort of cop-out. So they're then trying to attribute it to, the jets coming out of it and blah, 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 without actually explaining what the jets are. And so a planet discharging strongly will be changing its orbit strongly. And would you believe, one of the arguments against Velikovsky was, if Venus was the archetypal comet, according to all the races around the planet, then how come it's got such a circular orbit today? Well, the answer is because it was the archetypal comet and the most spectacular thing in the sky. You can imagine a comet with a head the size of a planet.
And the ancients actually witnessed that. They drew Venus with a long beard. It looked exactly like a comet. This is priceless information because we're all indoctrinated into thinking it's been there forever, it'll stay there forever. But the electric universe theory postulates that Venus began its life as a comet and finally moved into a relatively stable orbit. But there are telltale signs on Venus that show that it is, in fact, an outsider. Can you share some of those anomalies of Venus?
Well, it has a backward rotation and extremely high temperature, enough to melt some metals on its surface. The atmosphere is extremely heavy, and yet before the first space probes flew past Venus, it was thought that there would be life. It would be rather the twin of the Earth. So this was the idea. It's the twin of the Earth, and it might be a bit more tropical and everything, but nothing like the temperatures that they found. In fact, the first spacecraft that went past, they couldn't believe the figures, so they had to do it again. This is where your beliefs get in the way, you know. And Velikovsky, of course, was very pleased about that because he'd predicted it. He predicted a lot of things that the astronomers only later discovered. One was radio noises from Jupiter. This is before radio telescopes were invented. That was subsequently found. He said that Venus had been a comet, and then, blow me down, in the 1980s, a report came out and said, Venus has a cometary tail. What they meant was the magnetosphere sort of draped these twisted stringy things, they were called. Well, stringy things in plasma are electrical discharge phenomena. And anyone who's got a plasma ball, you know, one of those novelty balls, can see that the electric currents inside that ball travel in these snaking filaments. And that's what was discovered coming from Venus. But still...
they won't go to the electrical place.
No, it's only magnetic. You're allowed to have magnetism in space, but not electricity. And yet every electrical engineer knows that the way to produce a magnetic field is to have an electric current flowing along a wire or along something.
Yeah, that's high school. That's high school physics. Absolutely. So you're dealing with, in a sense, a traumatized humanity which just doesn't want to go there, because going there, they would have to remember that some serious disruptions happened in the solar system that our forefathers actually remembered. And the cause of those disturbances was the fact that we live in an electrical universe, not in a gravitationally bound universe. So if we go there, we would actually have to start thinking about that, and that would open up the wound. And I think that's where Velikovsky's genius really shined, because he could connect the human psyche to mythology, to physics, to planetary bodies. And all of this brings us now to your presentation at the yearly Electric Universe Conference, which I believe has been going on since 2012. And at that conference, you gave a landmark talk with absolute poker-faced calmness as you are lampooning Einstein and other people. I mean, I don't know where you get the chutzpah to do this. Nobody wants to go and challenge the top guy in the mafia, but you easily take him on. And your title was Elegant Simplicity. Now tell us a little bit about how the idea of elegant simplicity connects to the electric universe.
Well, there was a talk given at the in Canada, in Waterloo. What do they call it again? I've forgotten at the moment, but it's a well-recognized scientific establishment where they do astrophysics in particular, and cosmology. And I've seen one or two of the talks given there by leading figures. And the director of the institute gave a presentation on the simplicity of science, you know, particularly cosmology. And what did he do? He began with Pythagoras and mathematics, and it was mathematics from there on. And the things he was saying towards the end of the presentation and in answer to questions had no physical meaning whatsoever. It was just pure science fiction. So I thought I need to do a similar thing, only the simplicity of the electric universe is elegant. So it was the elegant simplicity of the electric universe model. And in that, I didn't just deal with the science, I also dealt with the problem of how humans learn or reject learning, you know, because once you've learned a bad habit, as a psychologist friend of mine out here in Australia has pointed out, you have this automatic mechanism of quickly, first of all, you reject what you've been told, and then you quickly forget it. You have accelerated forgetting. And this is typical. I can see when I'm talking to somebody who considers themselves to know quite a bit about the subject, that as soon as I start talking, they're thinking about objections. They're not listening to what I'm saying. And this is where it's better to come to the electric universe as a beginner, you know, with an open mind, because if you start setting up roadblocks right at the beginning, you're going to have a real struggle. I know I had the same problem when I started realizing that Einstein had seriously stuffed up science. And,
seriously stuffed up science. I love it.
and yet here he was, he's the all-time hero of science. But most people, I mean, they're not even taught what science is or how you're supposed to do it. There's probably as many scientific methods as there are scientists. And the method I chose was one of the natural philosopher. That is, you look at what's being said and the words that are being used, and you try to think, what does that mean? What does that actually mean? And that's not done very often, because when you listen to the language used on those science programs, a great deal of it is meaningless. It has no physical meaning.
This is a brilliant point, Wal, if I may add here. Somewhere in the 1940s, a guy called Alfred Korzybski showed up and created the field which is now known as general semantics, which means meaning. And he said that there is no way science can progress if we do not change its language. And so he suggested something absolutely revolutionary, which was, if we take the verb to be out of science, we'll have a lot more communication with disparate theories. For example, gravity is, the universe is, the speed of light is. When you say is, it's absolutely eternally true under any conditions. It's more accurate to say our observations suggest that the speed of light appears to be such and such within these parameters. However, those parameters are earthbound. We haven't checked the speed of light a billion light years away. So how can we say it is constant? And I thought this was a stroke of genius. If only scientists could adopt what we call E prime, English prime, no verb to be, we'd start really shifting things. And so that's a very wonderful comment, Wal. It's like, read what they're saying, think about it, really try to grasp the meaning. And if it doesn't make sense to you, chuck it out and go for something more forensic and obvious. And I think that's what you've done.
Oh, yes. For instance, if you look in the dictionary or encyclopedia, or even, physics literature, you will find E equals mc squared, where they specify E is energy, m is mass, and c is the speed of light. And then in a paragraph or two later, they're saying m is matter.
Really?
Yeah. They confuse the two. I think I've often said largely because they both begin with the letter M. Now, this is a critical fault, because mass is a property of matter. It is not matter itself. But as soon as you confuse the two, you consider the mass is the same as saying the quantity of matter. It's not. And this is why you cannot extrapolate what we observe and measure on Earth out into deep space and call it a universal law. Newton's universal law of gravitation has this universal constant, big G. It's the most inconstant constant in physics. It varies even measured on the Earth. And yet
How?
that's extrapolated out through the universe.
How is it different on Earth, Wall?
Well, every time they measure it, even using the same equipment in the same laboratory, it's different. And sometimes it's so different, it's well outside the error bars. You know, there's the errors of measurement and the equipment. So this is a problem that's never been answered, and yet we still have this in the textbooks. The speed, the gravitational constant G is such and such down to so many decimal places. Now, that is wrong, because when you look in the mathematics, you can talk about the dimensions of the variables. You know, you look at the speed, and it's got length and time dimensions, and you've got the mass, which has got its own dimension of mass. If you look at the dimensions of big G, it includes mass. But mass is a property of matter, so it depends on the energy of the matter, what that mass is, which means that G is not a constant, it's an energetic variable.
It's an energetic variable.
Yes, so when a spacecraft flies past a comet, and we're told by the authorities that it's only a fluff ball, you know, of ice and dust, and it looks like a piece of a planet, in other words, it's rocky, they measure this low gravity and say, oh, no, but it must have holes in it, or it's made out of, cornflakes. The thing is...
You challenged this cometary model of the dirty snowball early on in your work. Yes. You completely turned it into an entirely different story. A comet is an electrically charged object which interacts with other planetary objects. And as you've already said, we've seen comets since the advance of technology increase in brightness millions of times. The halo has suddenly expanded. At one point, I remember seeing one, it was bigger than the sun. A comet had flared up with a halo bigger than the sun. Now, can you tell me how a dirty snowball accomplishes that feat, Walt?
That's some snow, some ball. Yeah, the thing is that by using the constant of gravitation established on Earth, and then using that to decide what this object is made from, is completely misguided, because G is a variable. Everybody in the universe has its own constant of gravitation. But this is, as you mentioned, this is the geocentric problem. We measure things on Earth, and then the mathematician loves to then just, oh, I've got an equation, let's try it out there, you know, without any thought to the physical consequences of what they're doing. And this is where the mathematics is not science. You have to know the limits of what the mathematics you're doing actually has in the physical world. You know, Young's modulus is of no use to you if you've broken the spring by stretching it too far.
Well, you're up against Hollywood, and you're up against teams of scientists. All of the great shifts in science happen because of one man or one woman. That's clear. Mm. It never happened through a team of multi-billion-dollar researchers. And one of your favorite targets to lampoon is the Large Hadron Collider, which is the most expensive machine ever created by mankind, to find the God particle, which they've proclaimed has been found at a cost of multi-billions of dollars. And so now we know, we got the God particle, we know how it all happened. And this is the emperor with no clothes on, and you're the only guy in a room, stands up and says, wait a minute. Can you comment on that whole debacle?
Yes, the trillions of dollars that have been spent on that are a total waste of money, because they had the answer with that equation on the board, which everyone attributes to Einstein, but was actually found much earlier. It's an equation that can be derived fairly easily without any recourse to Einstein's magic. And that is E equals mc squared. Mm. That is telling them where the mass of matter comes from. Mm. But they can't see it because they've got no definition of mass, they've got no definition of energy, so the physical consequences of that equation are totally lost on them. What it's saying is that energy, mass, and the speed of light are all properties of matter. One sentence, that's all it takes. They didn't need to look for Higgs boson. Higgs boson is just something that they produced by feeding so much energy into all of the matter that it forms these little momentarily resonant particles. So this is why they've got this huge zoo of particles. If you go pumping energy into matter, it will restructure itself. Some of it will fly apart, some will form associations which last only for a fraction of a second, where they orbit one another briefly before disintegrating once more, just dissipating the energy in any way they can. So
the fabulous invention of particles, gluons, leptons, muons, it goes on, and they keep increasing. And for a serious individual with real curiosity, which is exactly what you are, and many of our listeners are, with real curiosity, we come to a place where we just start to give up. Like, I can't get this. Quantum tunneling, superpositioning. If the observer is not there, the universe disappears. It gets very, very strange, and it's become more and more acceptable in movies like Interstellar, where you have a very credible science expert will tell us everything in this movie is pure science, and everybody looks at it and goes, wow, so that's how it works. But nobody's made a movie yet about the electric universe. Nobody has asked our collective memory to go back to those petroglyphs, rock art, and memories, which are still engraved all over the world, telling us, hey, there's another movie here, and it's the one you don't want to watch, because it actually means something different for you. And at this stage, I would like you to touch on how the impact of this amazing electrical universe theory will help humanity, will actually move us forward and take us beyond this Babylonian speak of mathematical formulae. You're hopeful, and I think you're very positive that if we can understand that the universe is electrical, it's going to mean something for us. What does it mean?
Yeah, it unlocks our real past and that of the Earth, and that's a dramatic past. It's the irony of it all is that if Hollywood knew the story, it would blow any other story they've ever created right out of the water.
Yeah.
Because people would recognize it at some deep level in our subconscious. We remember that story. This is why fear is a big driver in humanity. And having it constructed on a big screen, I've always thought an IMAX theatre presentation of this I think people would just be overwhelmed by the story. And that's the critical thing, you see, to actually be motivated to try and find out what we didn't understand about gravity and the universe that we observe. I had to go back into the history, and that was where all of the questions, the real questions, were. Not the ones they make up now, which are a result of being completely off the rails. And those real questions had to be answered, I felt. So this has been the motivation for all my life, is to find answers to them. And they had to be simple, and they had to be real. And this is the thing, when people get to know the electric universe model, they say it just makes sense because it relates to everyday experience. None of this nonsense about black holes and so on. And
it's not just that it makes sense, though, Wal. I mean, it's predictive. You actually predicted, which is what scientists are supposed to be able to do. You predicted that something would happen on a certain comet at a certain time, and nobody else, as far as I know, was predicting that, because they all thought it was a dirty snowball. You predicted it, and you were right. Can you tell us about that episode?
Yes. When the experiment called Deep Impact was first broadcast, back, it was 4 years before the actual event, I think, I wrote about it on my website, and I predicted what would happen. I said that there would probably be an electrical flash before the impact, and that the outburst from the comet would far exceed what you would expect from a mechanical impact. So they had this craft which was split off from the main craft, and which was flown in such a way that the comet would collide with it, because the comet was traveling at phenomenal speed with respect to the spacecraft. It only had a few minutes really to record all of this. And that's exactly what happened. I was watching the broadcast from the control room as it happened, and there was this flash, and people said, "What was that?" And then all of a sudden, the thing just lit up, and the outburst was so bright that they couldn't actually do what they wanted to do, and that was to film the crater, so they get some idea of the structure of the comet. I also said that the physical crater would not be significant. I said some of the jets that were coming out of the comet would shift position because the electrical environment would suddenly be changed with all of the copper ions and that floating around the nucleus. And all of these things happened. Now, the Time magazine at the time picked up on that, or Wired magazine did first, and my website crashed under the onslaught. And Time magazine picked it up, and they wanted to do an interview with me, but it was quashed by experts.
It was quashed by experts. So you had known that a metallic spacecraft, which is approaching an electrically charged object flying through space, would create, for lack of a better word, an electrical discharge, a plasma discharge, that sparks would fly, in simple language. That's exactly what happened. And that millions of dollars and years of scientific research, not one person had been able to predict that. You did, which is pure science, absolutely pure science. You're then ignored by Time magazine. So it only goes to show that Schopenhauer was correct. Violent opposition is where we are now. In fact, it seems to be getting worse than ever before. How do you see it now?
Well, there's been no improvement. I don't expect that the mainstream scientists will have anything to do with us until they're forced to. I mean, we'll have the skeptics and that doing their best to try and turn people away from us, but don't be put off by them, because a skeptic is like a born-again believer. You know, they turn from one belief to another, and one of the belief systems today, of course, is science. It is a belief system, first and foremost. And so my view is, and has been ever since I teamed up with David Talbot, my mytho-historian colleague, that the change has to come from underneath. In other words, the public has to realize that there is an alternative story and be able to compare it against the one they're being fed for all these years, for a century now, and do the comparison themselves and come to their own conclusions. Only when the public demand the scientists address these issues will they be forced to do it. But they will not do it voluntarily.
They will not do it voluntarily for a variety of reasons. And, you know, it must be said that none of them are obviously acting out of malice. But when you get into a certain mindset that is supported by everybody, whether it's religion or science, it makes no difference. It is extremely difficult to go out on the edge and to challenge it. And you've been able to do that. You started the conferences in 2012, the EU, of course, meaning Electric Universe. They've been incredibly successful and drawn a huge amount of interest from ordinary people like myself. I don't have a scientific training at all, but I'm inquisitive. I'm interested in many different fields. And when I came across the Electric Universe, it was like, wow, this makes sense. This is simple. I can get this. And it connects to all other aspects of our lives, to biology. We're electrical beings. Yes. Everything we do is electrical. Our heart, our brain. We're connected to an electrical planet, which is connected to an electrical sun. And one of your guests, I remember at one of the conferences recently, was Ben Davidson, who's actually managed to crowdfund an app, which I use, a disaster prediction app that with 80% sometimes accuracy can predict when an earthquake is going to happen and where on Earth due to changes that are happening in the solar environment. Now, you
Yes.
can't poo-pah this kind of stuff. And he was a lawyer, not an astrophysicist. That's interesting, isn't it?
Well, this is the thing. The electric universe can appeal to almost anyone, and we encourage people to contribute in one way or another, any way they think they can, ideas or funding and so on, because we are a charitable organization, the Thunderbolts Group. And right from the very beginning, I realized that it had to be a group effort. I couldn't do it on my own. And so over the years, a number of wonderful scholars have joined in. And so we've got people from all different disciplines who are all working together with the same coherent cosmology as the basis. And that is a great thing, because science has become so compartmentalized now that specialists in one field cannot even talk to people in the same field if their discipline is doesn't focus down on this narrow part of it. So I could say to the scientists, who I don't blame, I can understand their situation. I wanted to be one once. Don't take what a specialist in one narrow field says as necessarily the truth, because their specialization is so narrow that they may be missing something that somebody else down the corridor could tell them if only they had an overarching model to work with. They don't have one, I mean, the Big Bang has practically no sensible application to our everyday life at all. All it does is give specialists a chance to ask for more billions in funding for the next crazy experiment, when all of the answers are actually sitting right in front of them if they knew how to ask the right questions. It's
paradoxical that we are in the most electrically powered age of any time in humanity. Everything we do is powered by electricity. Every moment is concerned with electricity. And yet, despite all of this, we've missed the big elephant in the room, which is, hey, it was all electrical from the very start. And of course, my question was, and always has been, maybe it's a devil's advocate question, but where does this electricity come from? How did this electricity come into being? You must have asked yourself this question.
Yes. This gets down to our deep need for a creation story. And we don't understand what the original creation story was. We try and attribute it to the creation of the universe, which is what the religions have been how they've been interpreted. What it actually was the creation of the skies we see today from something that was completely different. If we could be transported back, 20,000 years, I'm sure we would be frightened out of our wits because we wouldn't know where we were. So the creation story, obviously man wasn't around to witness the creation of the universe. That's nonsense. And there was nobody to pass on the story about it. The thing is that we are at such an infantile stage in our science that we can't even pose the questions correctly. The electric universe goes much further and identifies the real questions at the heart of it all, and that is, what is matter? And here you get to look in the opposite direction. Instead of looking out into space for billions of light years, we're trying to look down and drill down into the atom and then the electron and the proton and find out, what is it? How do you create this stuff? Because there's no such thing as pure energy. Energy is a property of matter. So the Big Bang is nonsense. You cannot make matter from pure energy because the matter's got to be there to hold the energy in the first place. There's a radio astronomer chap who I have in high regard, and I've met him and we've corresponded a little, and he's written some interesting books. But he once said, who are we in our arrogance to expect that to have the answer to the beginning of the universe within the first microsecond of asking the question? And that's my point too. Our understanding is at such a rudimentary level largely because we've wasted an entire century since Einstein, that the question is meaningless. All we can do is talk about what we observe, and what the radio astronomers observe is that throughout the visible universe, there are these radio emitting huge filaments along which are strung spiral galaxies and galaxies. And then within the galaxies, you find the stars are strung along the main discharge channels, which form the spiral arms. In the sun's environment, we see that the sun itself is not a thermonuclear bomb. The standard model of the sun was made back in the gaslight and horse and buggy era, when they first discovered that you could get energy out of the nucleus. Plasma physics at that time was in its infancy, which is unfortunate. If we'd been the other way around, we might never have gone down this false trail. No, there's much more to it. We have to understand matter first. That is the critical thing. We have to understand matter, understand how it produces gravity, how it produces magnetism, and how it responds to the external electric force. We will be much further advanced when we do that and stop talking about gluons and all of these other magical mathematical contrivances, because matter cannot wink in and out of existence. And yet the standard model of the proton is a plum pudding with all of these quarks and anti-quarks and gluons and that whizzing around and disappearing and reappearing, you know, which is pure science fiction. No, the electron and the proton must have an electrical substructure. And some of the big geniuses of the past already had figured that out. There's a lot of, you know, nothing new under the sun about the electric universe, because when you look at the real history, you can see that people had these ideas in the past, but they've all been forgotten since Einstein, because the mathematicians took over physics. They usurped it. The natural philosophers were tossed out.
Yeah, they forgot about geniuses like Christian Birkeland, from whose name we get Birkeland currents, these spiraling, electrically charged, invisible movements through the plasma. Hans Alfvén, who actually won a Nobel Prize for the theory of plasma cosmology. Nobody knows these guys, but everybody knows the so-called geniuses like Einstein, and one of our recently deceased scientists he was absolutely sure he'd figured out the black hole, and we all worship him now. But what if that was all wrong? We have to be courageous enough to think it could have all been wrong, just like they were wrong about the flat earth, just like they were wrong about there ain't no water on Mars. There is water on Mars. Hello, look around, look at planetary scarring, electrical discharges all through the universe. Look at your body, look at the sun. Start looking and stop thinking. That's what you're educating people to do, and I think it's a wonderful movement, and I would agree it's not going to happen anytime soon, but I'm seeing the conference grow and build, and all of these eclectic scientists. You got Bruce Lipton in there, you got the originator of the morphogenetic field theory in there, you got thinkers of disparate disciplines, and they're all thinking, how can we come together to understand this single thing called electricity? Because if we do, what does it mean? If it really is an electrical universe, it means we're all connected.
Yes.
We're not lonely, isolated objects floating around in a giant void. We're all connected to everything else in the universe all the time, instantaneously. Well, I think that's a hopeful idea. Do you get this response from people?
Yes. In fact, I call the Big Bang cosmology a hopeless cosmology, because it all ends up fizzling out, or another crunch or bang or whatever.
Absolutely.
The electric universe, on the other hand, offers the almost spiritual feeling that we are connected with the intelligent universe. In other words, the universe, the information that it holds, we are a part of. We are sort of the self-referential part. We observe, we witness whatever we observe and witness is available throughout the universe. It just opens up so many new ways of thinking about things. I think it's also important, you mentioned Hans Alfvén. He was the Nobel Prize winner of physics in plasma science and the pioneer of plasma cosmology. if you want peer-reviewed literature in mathematics, which is tested against experiment, read about plasma cosmology. There was a popular book called The Big Bang Never Happened by Eric Lerner. That's a relatively easy one to read, and that outlines what galaxies are. So plasma cosmology deals at the big end of the picture, and it explains why you don't need black holes. It's all electrical in the center of a galaxy. You've got a lot of energy concentrated there. It means it appears as a lot of mass. It's not a black hole, that's for sure. And it also explains easily why you get these jets with high electric currents flowing along. Anyway, apart from all that, I think there is, in my opinion, a good argument for the continuation of human life on this planet. The way we're behaving right now, I don't think it has any long-term future without coming to terms with a real cosmology and an understanding of our connectedness to the rest of the universe.
And with each other, of course.
That's right. The same way the sun, will I grab that and just knock it off?
Sure, no problem.
Hello.
An electrical phenomenon has just occurred in Wallace Thornhill's office. That was electrical disturbance. That was great.
What I was going to say, though, was that in the same way that the sun knows where the earth is and vice versa, we are connected by that same kind of signaling. That connectedness applies throughout the universe.
So for young people who are pretty much dissuaded from going into science unless they're mathematical whiz kids to begin with, because there's no way you can go there without math, something I was never good at. But if they can be encouraged, and I was very happy to see your brain, the discourse on the two hemispheres of the brain and how different the left and the right hemispheres really are, and how our educational system is almost totally concerned with left brain type analytical narrowing into specialized fields which separate things. I believe one of the original meanings of science from Italian, it meant something like scire, which means to cut into little bits and isolate and check those little bits, which of course is redundant, because that little bit has to be attached to some other little bit to actually make it a little bit in the first place. They got to be connected. So it's a hopeful idea. More and more people are getting involved. Tell me about this year's conference, which is going to happen in Bath. Who are some of the people who will be coming?
Yes, this will be our first expedition outside the United States. So we were offered the possibility of doing our conference this year in Bath in England. It's July the 7th and 8th in Bath itself. And then for those people who would like to talk to the presenters and so on after the event, there's 3 days for a small number of people in the countryside near Taunton, which is not far away. So, but the conference, the main conference, which will have presenters from our electrical experiment that's being performed to show that the sun is an electrical phenomenon first and foremost, in Toronto in Canada, they will be there.
Well, tell us a little bit about that, Walt. What's that? What's this experiment?
One of the pioneers of the electric universe, although it wasn't called that at the time, was a fellow called Ralph Jurgens, an engineer from Flagstaff, Arizona. And he did an amazing piece of work in the early 70s, detailing all of the phenomena that we see on the sun and above the sun, and explained it in terms of a searchlight, an arc searchlight. And when I read it, I thought, this guy's got it. He's hit the nail on the head. Well, since then, I met up with a retired professor of electrical engineering, Professor Donald Scott, and he joined us in the early 2000s. He'd also been inspired by Ralph Jurgens' work, And so he and I have worked together. And the experiment in Toronto is designed to test Ralph Jurgen's model, and also to test the results that we get in this huge steel chamber against the conditions that spacecraft are measuring in the sun's atmosphere. And so far, we've done phase one was a bell jar little experiment just to test that we would get the kind of phenomena we wanted to see on the surface of the sun. We did. So we went to phase two, that was funded, where we had a much larger chamber with a lot of instrumentation, the best we could get to measure all sorts of things, everything we could think of, you know, spectroscopic measurement of atomic masses and so on, of species in the plasma, and Langmuir probes to measure the electrical structure of the plasma inside the chamber. That was successful and was showing signs of something that I was hoping to find, and that was what is the total energy output of the sun due to? Because you can't just assume that it's like a radiator or something, that you put the electrical energy in and you get a certain equal amount of heat energy out. That's not necessarily the way nature works. It does things very simply. So you have to be prepared for that. And this is what phase three is all about, to test what is going on at a much finer detail, right down close to in the photosphere of the sun, so to speak. Of course, the most obvious reason for doing the experiment is that when you look at the sun and you have that bright photosphere shoved aside by a sunspot, it's cold down there. It's cooler. It's over 1,000 degrees less, which suggests that there isn't energy from inside the sun trying to escape through the photosphere. The photosphere is an electrical phenomenon right at the very top of the ionosphere of a large body, which, according to the way stars are formed, will have a heavy element center. In other words, like a giant planet somewhere down underneath. Now, this is a completely different picture.
Completely different. Wow. And so you're actually experimenting, you're getting funded, you're doing the science right now, as well as the conferences, ongoing research with people all around the world. If people want to find out more, they can go to thunderbolts.info, or they can also go to, I think it's holoscience.com or .org?
Yes, that's my old website. It gives you kind of a historical progression of ideas from back in the early 90s. I think some of the earliest information I've got up there is later in the 90s, 1996 or 7. And you can see the progression of ideas, because this is a work in progress, always has been and probably will be into the future time. And the beauty of it is that every year we give a conference, there's been something new to report. A new way of looking at something. But never have we had to go back and say, no, the whole thing's wrong. It's just a case of you suddenly realize something is simpler than you ever thought before. And it's always lovely to be able to present that, because then people say, oh, yeah, that makes sense.
It really does make sense. And I congratulate you for the enormous amount of energy you have expended. You haven't done battle in any negative, nasty way like so many of the skeptics. You've always maintained your calm. I've seen in so many presentations a calm and rational explanation for what we see and how we may be able to explain it through electrical processes. And that's been your saving grace, because lots of other people, I think, would have just lost it. Well, seeing the way science has gone in the last 20 years, it's just so absurd. Any rational person would have to say, what are you guys really talking? Time travel, multiple dimensions, wormholes, black holes, dark matter, dark energy. I mean, come on, guys. Is that the best you can come up with a budget like that? Really? Multi-billion-dollar budgets, and that's the best you come up with? We can't find most of the universe. Oops. Well, sorry, but I think me and a lot of other people are going, nah. can't do that anymore. And thanks to the internet, now we can access your phenomenal body. I mean, hundreds of videos about every aspect of the electric universe. That's why today I didn't want you to explain the electric universe. You already have a body of work. That would be redundant. I wanted to focus on where you had started and how your journey has been as a pioneer, as a true pioneer. And now you, like me, are no longer a spring chicken, and you're looking back on a life of incredible research. Now, if you went back and asked yourself as a young student, or you could meet yourself, we know that time travel can't happen like that, but let's say you could. And there's the 20-year-old Wallace Thornhill standing there, and you go back and he says, well, what's your advice for the next, half century? What would you say to that young Wallace Thornhill?
Well, I think I would say don't be in any hurry. Because when I first teamed up with David Talbot, and the other thing I would say to myself too is follow your intuition. Your intuition is a kind of connection to the universe, and it's something that you shouldn't just ignore. And my connection with David Talbot was due to intuition. And I collared him at a meeting that he set up in 1994, where he felt that his film, Remembering the End of the World, which is one of the YouTubes available on our website, would be a big hit and would bring all of this stuff out into the open. I'm glad it didn't. We weren't prepared. So what I intuitively understand is that I don't have to know how it's going to work. All I have to do is maintain the vision of where I want to go. The Sapphire experiment, the sun in a bottle experiment, as they call it, was a case of following my intuition. The engineer who's heading that up just rang me from Canada out of the blue, wanting to help. And that was the result. And this happens a lot. People write to me and say, I've got this idea, or I'd like to help. The meeting in Bath is due to a call, one of those calls. So let the universe guide you by your intuition, and don't be in any hurry, because a lot of these ideas, you have to drop your old certainties, and that takes time. The longest time has taken getting rid of things that I thought were absolutely certain.
Well, as they say in Japan, there's a great Zen saying, great doubt, great faith. And that says it all. That really says it all.
Yeah.
And you've lived that, and you continue to live it. And I wish you well on your birthday tomorrow. We're letting out again. It's a well-timed interview. And I do hope that many people will tune in and get connected to the electrical universe. And on that note, I would thank you today and hope that we can meet again at one of the conferences, or at least speak again about this astonishing idea. Thank you very much, Wal. Thank you.
Thanks, Ekman. Thanks for the opportunity.
Not at all. Bye-bye.
Bye.
Welcome to Real Rover. I'm your roving host, John Craig. Real Rover へようこそ、Craig John でございます。Introducing you to people you would never have heard of if it